Okay. So previous section we are discussed the application tires. Okay, different tires there as per the requirement. I mean, as per the application infrastructure, we need to create different. I mean, the tires segment. Okay, how many tires that each specified application needs, or how we. I mean, how we. You know architecting the application. Okay, all things related to the specific application, and after that we need to finalize. Okay, how our application and our application infrastructure like look like this or like that. Okay, and so many. I mean, coming to security, then scalability, availability, then so many things. I mean, these are the things we will get. Okay, I mean, when we deploy our application in different tiers. So we learned that three tier application, right? One, tier two, and tier three. Yes. The tier one is the front end. This is the front end, and this is the API, and this is a backend. This is a three-tier application. So first is user hitting the front end and access the application. In any other request, if any users need, I mean through the API. Okay, I mean API will get the backend things and send it to the user. So this is a three-tier application. So today I will explain some. I mean not three-tier or two-tier. There is a 10-tier application. Okay, means 10 different tiers there. Okay, 10 or 12. That. For example, I will explain. Okay, like this is a front end. This is our application one. Okay, concept. This is pod one, and we have one more application. I mean, these are microservice application. Meantime, I will spin up a Kubernetes cluster. Sam, that. Because I need not three-tier my three-tier. I mean, sorry, tier three. I need T2 medium. T2 medium. My origin is same, yes, is the one. So I need to change my EKS cluster, EKS one. Then my non-group name, I will change as not type is T2 medium, and it's managed by EKS, by many EKS, and I need 3 worker node. Okay. So this will create Kubernetes cluster. This will run in back. And yeah. So coming to the architecture, okay. So yes, 10 tier, right? So we'll learn more. This is another service. Then here another service. One, two, three, four, five, six, seven, eight. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 service. And not full service. I mean, some parts are not a big. I mean, some small script or small language learning background. Okay. I mean, in a single pod. So this is my front end. And this is like a e-commerce application. Okay. Like a boutique application. So here there is an ad. This is one of service, and another service is recommendation. Production catalog. This is ship cart. Okay, cart. And we have a small Redis cache database. Redis cache. Then checkout. Payment. Email. Shipping. And currency. So all services are connected. Okay. First hitting the front end. So there's a connection between front end and same way front end will connect with all the services, right? So the recommendation will connect it with the production. Each service are leveraging each one. Okay. I mean, it's all integrated or interconnected with the different. For example, when we are going to uh, purchase something in online, okay, like Amazon or Flipkart, we know that we go to add items and add some products in carts. Then we need to billing the thing. After billing, we will get a mail. So all things same way we are creating this application. See, all things I will integrate all the things here. So the user hitting like outside well to our cluster. This is user. Okay, here. Here we set up a load balancer, LB or load balancer. Okay. This is the protocol is HTTP. Got it. And all the services, all microservices are running inside a Kubernetes cluster. And one more thing, as a developer's perspective, each services are written by different language. Okay. For example, this is microservice. For example, sometimes we need to modify or add some features in each. I mean, for example, some yeah here checkout. Okay, there's a checkout window we have, so we need to update or add some new features in that part. Okay, I mean that small service. So we can just change the thing in the single microservice because this is running in a different language most probably. For our application, our front end applications language is Go, written by Go. Okay, then cart C hash. Again, production catalog services, Go, same language, Go. Currency service, this is currency service running with the Node.js. If the application is monolith, only one single language will provide it. Okay, there. Currency service and the payment service both are running with the Node language. Then shipping, Go, and email service, Python. Then coming to recommendation, Python. Add service, Java. And the load generator, Python. Yeah, see, now we will get some idea, right? I mean, why we choose microservice and what are the features, I mean, benefits when we are switching into microservice. Nowadays, most applications, I mean, the monolith applications, legacy applications are transforming to microservice. Okay. So here, the port-to-port communication happen via a port number. Okay, for example, each pod have their own network and port all the things, right? I mean IP port number. So for this architecture, we are using gRPC node. Okay, there is a service. So through the gRCP, each node communicate. Okay. So anyone have any doubt? Anyone?
Yeah, I think you explained. You said if everything like this, if everything is in a same language, it means it's a monolithic application.
Hmm.
This is what you said, right?
Yes, this is microservice. And the traditional way how we deploy through monolith architecture. Okay, in coming to monolith architecture, there is no different service. All things wrap up in a single service and written by a single code. For example, our application written by Java, all related services in a single application running in the same code. You couldn't change the code or anything like that.
Yeah, I'm talking about the language.
Yeah.
Okay, so okay, thank you.
Okay. All clear, right? All of you.
Sir, I have a question.
Hmm.
Sir, there is database.
Sorry.
Database.
Yes, this is the database.
Is there any database for this layer? I mean, this 10 layers.
That is not, I mean, coming to this Kubernetes, okay. We
Mm-hmm.
just keep our database as private. Got it. For example, how we say, like each service have their own services, right? I mean,
Yeah.
service.yaml. So
Mm-hmm.
for the front end, our service type is load balancer, right?
Okay.
And for example, for database, our service is cluster IP. So there is only internal connection. I mean, communicate with internal. Like that, we can segregate our database.
Okay. So what I mean to ask you is, like, when the layers are there, there will be a database layer, right? So I was thinking in that way. And mm,
Got it. I mean, in this case, our database in a layer, but we didn't count as the layer 10 or 9. But our database in a layer and our database in private.
okay, ready stage. Okay. Mm-hmm. Okay, thank you.
Each application is in different layer. Okay, this is a 10. I mean, around 10 or 11 application tier application. Got it. Tier
Yeah,
application.
I understand.
Ah.
Yeah.
Layer cluster is under 3. Yes, see, our cluster is up and running. Fine. So, yes. Okay. So in my case, I have the YAML file. Okay, in a single YAML, all services are mentioned. I'll show my YAML. See. mm, yeah. This is my YAML file. Okay, and the first, yeah, starting from here, deployment. So this is a deployment for the email service. First deployment. So this is uh this is a sample application of Google service. Okay, GCP. So, and here I mentioned the port 80. Then for the same, there is a service. Okay, API version service. So email service. See, this is for cluster. I mean, the type is cluster IP. So this service didn't expose to public. Only communicate internally. Okay. And coming to the port. Okay. See, here we are choosing a service called GPRC, gRPC. Okay. And the port number is 5000. So most of the port we are using this port number for intercommunicating. Okay, so all services are related. Got it? I mean switching. For example, first I am going to my card, then I need to choose payment, then it will jumping to one application to another application. Okay, I mean port to port jumping. Now next deployment, that is called checkout service. And for the same application, there is an image. Okay, each application, there is an image. I mean, each services, each microservices have their own image. And again, we are provide the for this application. I mean, for checkout service, we provide the gRPC, same port 5050. These are the values. Okay, in environment, we can see the values and the names. For the same, we have one service. C. We are using cluster IP for this deployment. Then recommendation services. Okay. So we have one image for the same, then service. Here we are using cluster IP. Then coming to front end, this is our main application. Okay. So this application we need to face to public. So this is a front end. This is our application. I mean image. Here we are provide not ERCP, we are providing the port number 808080. And you see the path health, the health checker happen here. cookie section. See, for our front-end application, the service is load balance, okay. And this is a huge YAML file, okay. So we need to integrate all each services and each deployment, each services in a single YAML file. See, it's a lot of similar way we provide each service and each deployment and service and the port number, image respectively, okay. Yeah, it's done. So coming to this is add service. There is our this. I'll show the yeah. So this is our database, okay. Redis database. So the deployment is Redis card and see the image is Redis alpha. It's a small size database, okay. And see the Redis tar is, I mean, we keep it as cluster IP same way. So the our application, I mean the microservice database application is in private tar. Okay, so in our case, all thing is ready. So we can directly deploy our application. See, all things are deployed. See, yeah, our pods are creating, containers are running. Okay, that's why it's 0 by 0, 0 by 1. Container is not up and running. Some cases. And see, this is our service for load balance only. We expose our application to load balance. That's why we get a URL number, URL for accessing the application, and all others, all are cluster IP. We keep it as private. And this is our deployment. This is our replica set. So once again, try with the kubectl. Yeah, now it's all are running. See, all pods are running. Yeah, there is total application. Okay. And we can directly access our application through the load balancer URL. We need to wait a couple of minutes. I mean, yeah, it's done. Because the backend load balancer is running. So this is our online application, boutique application. So we can choose, and here we can add and add to cart. So each see when the URL changes, that means we are switching different ports. Okay, I mean different containers. And this is one of the applications, right? Like US currency and the card. This is another application, microservice application. Place order. Now we are in the payment. So this is another application. These are the cards. Your order is completed. We didn't integrate with the mail or anything that. So this is the way. So my cart is this is a way we deploy microservice application in Kubernetes. Okay. I mean with the different, I mean a lot of tiers. Okay, like 2 tier or 3 tier, 4 or 5. As per our application, we will keep each microservices in different tiers. Anyone have any doubt? All of you?
Yeah, the problem of writing the code is the problem. How to
So-
write those codes is a long one.
The YAML, right?
Yes, yes.
No problem. This is I am for a easy purpose. I keep all the YAMLs in a single file, but in the main program, the each services YAMLs are segregated. Okay, so don't worry about that. For example, the front end application and the service, there is a single YAML like that. And one more thing, for each services, I mean each microservices, there is a Docker container running. Okay, that container we specify in the YAML. Okay, as image.
Can we find out on Google the templates of a YAML file in order to modify things and use it?
Which YAML file? The same. This one. You mean deployment YAML, right?
Yes.
See, this is a YAML file.
Yeah, hello.
Yeah.
Yeah, my issue is normally you created this YAML file like deployment and services. This one has a lot of like a microservice with a lot of YAML file on each
Yes.
service. And how do you create that at a go in order to have them according to each other like this after the API version? App one, when it's completed, it's followed by other one, it's followed by other one, and then they are all having the same function in one infrastructure. How do you
Yes,
create?
yes. I mean, port-to-port communication, right? I mean, for example, now I am in a cart, okay, see, cart. Now I am switching to main application, front end, okay. This is my front end application. And now I am going to products. See. So,
Yes. So
yeah, each services are accessing through gRPC. Got it. What is gRPC? This is a call type communication. Okay, I mean, same similar like a API, but we are using gRPC for containerization application. Okay, I mean, in coming to microservice, this applications know this application is or this application is using gRPC port number. Okay, so we can access this through the port. Okay, the default port is 5055050. Yes, right. So the front ends know each one. I mean, each one have the same gRPC. They can. I mean, the main service can easily access each application. So why we are choosing this? It's fast communication. See, you can switch into from one to another, right? So each one have different microservices. Okay. Then going to cart. See, I'm easily switching from one service to another service. These switchings first hitting the gRPC access, okay, through the port number.
so gRPC is the one letting the services talking to each other internally.
Yeah, yes, microservices. Yeah, we are using GRC for microservice users for high volume of calls to communicate each others. I mean, each services.
So, yeah, so that means how do you know how to configure gRPC now in order to have them talk to each other? I don't know. I have no idea.
You mean the architecture, right? For example, I have a, yeah, I have one application, okay? I mean, one microservice application. This is my front-end application. And for the same, I have one cart, okay? This is a e-commerce, similar like the e-commerce application. So when user coming to my front-end application, okay, front-end, then they will choose, I mean, they will select some products, then they check out, okay. At the checkout time, the checkout time, there is, we need to switch this window to another window, right? So this window, the front-end windows will maybe written by a language like Python. And this is my cart, okay? This is front end. And this is my cart. Cart is another small application, microservice application, and written with another language like C hash. Okay, consider. So when the user click checkout and bill payment or anything like that, at the same time, we need to switch from this pod to this pod, okay? I mean, this is a pod. This is in Kubernetes case, okay? And this is another pod, okay? And the front-end application in a container, right? So from this container to cart container, okay? So how this switch, I mean, how this call happen coming to microservice, we are using GRCP, okay? Yes, you see. And in the YAML file, we specify the GRCP and the port number, okay? Like 5050. So this request know that is switching to the similar, I mean, corresponding services. For example, if another service is here, okay, like, so we need to finalize, okay, I mean, we need to set up these things. I mean, if there is two service, I mean, two microservice, then we need to find out the workflow and all the things. Then we need to specify the GRCP or no, any IPA or anything like we need to specify. Got it. In this case, there is a lot of tires. That's why we are using GRCP, so we can call each services very fastly. Similar way,
Yes, I understand.
Yeah.
I got it. But how are you going to configure them for you to be able to have all those services together? Because you created cluster, you just execute, and then you created cluster with T2 medium, and then all of a sudden you have the deployment in there. Which how are we going to do it to get all that one with the GPRC to talk internally? How are we going to create those CMS file? You know, the deployment, the services, the load balancing.
Yes. All things are in my single YAML file. See, in this file, all things.
How are we going to create it? How are we going to create this? Is it created already that you just have to go to a site and pick it up, or you have to create it yourself? That is
No,
what
no,
I'm
no, no, no,
asking.
no, no. This is official, Google's official application. See,
So it means this was created when, like, if you're about to create an infrastructure for a company. So
no,
this
this is
was
demo application. This is a demo application, and they will demonstrate how a 10 tera out 11
Excuse
tera.
me,
Yes.
excuse me. Is a gRPC shipped in with Kubernetes clusters? That's how we are able to leverage on gRPC.
Yes.
Okay.
so my concern is how are you going to create this demo? How do we create it?
Yeah, I'm creating with the YAML file. This is deployment file.
Yeah, can we take us? I mean, what
Is
them step by step so you can show us and show where to place this GRCP, where to place the port numbers. Like I have the same issue, the same concern, the question.
Yep.
I mean, about what he's
I'll show
asking.
you. I'll show you. For example, this is our email service. Okay, coming down. See, GRCP port. Coming to our service for the same deployment, we create a service for email service. So the name is here, the port name is GRCP, and the port is 50,000.
So what's the difference between the GRCP port, which is 5,000, and the target port, which is 8080?
Target is 8080, means our front-end application runs in the target port 8080. So that will communicate with that port.
So when we
So
go to a company and they want us to write this YAML file, what do you think we can do? How to start?
I think
Sorry.
you will confuse about a single full YAML file. That's why, right? I will segregate each YAML file. Okay, for example, each services I will keep separate YAML file. So you will get the idea. Otherwise, sometimes it's
no,
confused.
the idea is there already. We understand the
Then
each YAML file, like
excuse
for
me,
example, from
excuse me. I want to add some information here. If someone want to use it from the browser or outside the cluster, they use target port. But within the pods, these all are containers. If one container want to speak to another container, then they leverage on the gRPC. Because one container want to remotely invoke something on the other container, then it needs a gRPC.
Right.
I understand now, but my point is when you put all these containers together, each container has this YAML file, and it's like they're all together. So I know that each of them has gRPC supposed to be specified in every YAML file and every server. How do you create the whole thing at a go? Or it's created, each of them, and then they paste it under, or there is a command. There is a command you can execute, and then you can get a YAML file. So is there a command that created all this, or it's created manually one by one, and then they put it together? That is why my question is.
Yeah, both way we can set up the things. I mean, we can put all the thing in a single file and we can deploy the thing, or else we can keep different YAML file and apply each one. Got it? Or confused?
Okay. No, I'm okay. So
For your lab, I will send the separate YAML file. Okay, so you can analyze. I mean, first you deploy the front end, then the second microservice or any service. Okay, after you apply all the service, they will intercommunicate. Okay, I mean, all things we provide in the YAML file, and all
I
microservices are,
understand.
yeah, their
Yeah.
communication via the gRPC. Okay.
Yes, I understand now. So that means the gRPC, you specify the gRPC under the network environment.
Yeah. And most of our
That is
application
when
is
it
in
means.
yeah, most of our applications in private network. I mean, we are providing the cluster IP. Only front end we expose to public.
Yeah, thank you. I'm getting it now. It's coming closer.
Yeah.
Thank you.
Yeah.
See,
our all applications
thank you, Kapana.
Only the front end application, front end external applications using the load balancer. And these are the gRPC. Okay, this is gRPC, man front is gRCP. This is gRCP, this is gRCP.
So don't we have a specific port for the gRCP?
No. For each gRCP, we are using different ports.
So you by yourself, you can determine which port you want to use, or how that works.
Sorry?
So how can you determine, like, this one are gonna use 70, I had to use 5,000, I had to use like other number? How you gonna know you're gonna use different, or you can decide by yourself to use any kind of for
These
the
are the
gRCP?
ranges of IPs. You see the
Okay.
ranges. Yeah, so we can choose the port number and name it as gRCP.
Okay, it's a range.
Yeah.
Do you know, are you going to Google like from what to what?
What?
What's the range? What's that range for the gRCP? What's the range?
These are internal ports, right? I mean the container ports. Okay, this is our port. And this is our container. Got it. So here container have IP, right?
Yes.
And port have
IP also, right? Yes.
IP. So both infrastructure have their own IP. How the Kubernetes communicate with the container? Kubernetes didn't directly communicate with the container. They communicate only with the port, right? So the pods have their own IP and the container have their own IP. So coming to container, we can choose the corresponding IPs. I'm sorry, the port numbers. Port number starting with the 0 to 65,000, 5,000 and 535 or like that. So in between, we can choose the corresponding ports. Okay. So that's
Okay.
what that's we can see in here.
Thank you. It's clear now. So my last question is this. With the GRCP, you can easily communicate inside the YAML file. You can easily communicate between different language like Python, Java, Go, everything combined together in one YAML file. With a GRCP, you can, everything can communicate to each other, right? Or to one another.
Yes.
Okay.
That's why using GRC. Why we are using that. See, in a typical company, you have got hundred of services now, and GRCP is the best technology for the API for those microservices because it is of focus, it is efficient, and designed for inside the data center use case. But it's not right technology for connecting to your application. Got it.
Okay.
Yeah, it's clear because it's function like API, but I think this gRPC is much more better than API.
Yeah. If you are more application, in our case, there is 12 application, 12 microservices. So our application deployment is done. So anyone have any other doubt regarding deployment?
So this deployment is in your GitHub account.
In your
It's in your GitHub that we can fork.
yeah, I will share. I will share the GitHub repository. So there's a single YAML file and segregated YAML file there. Okay, for each deployment. Anyone have any doubt? Fine, right? For the same application, we can monitor using Grafana, Prometheus, and all things. Okay, just using the Helm and deploy the observability parts like uh, monitoring this microservice application. If we have time, then I will show. Then if there's nothing, then we can wind up, right? of you?
I
Yeah.
need to. You said no. You will show the other
Sorry.
deployment also.
Yeah.
You
Once again.
you said you show the other deployment, right?
Hmm.
I have time. I can sit for some more time if others are okay.
Your voice is not clear actually.
Is it okay?
Yeah. Once again.
Sir, you said no. We have time. You will continue with the some other deployment.
Hmm.
I wanted to. I'm okay. I can wait. That's what I wanted to let you know.
I mean the Grafana, right?
Yeah.
Yeah. I mean for Grafana.
If others are also okay, they can
Grafana.
stay.
Yep. For Grafana, we need to install the Helm. Then we need to using leveraging Helm. There is a package there for Grafana and Prometheus. So we install that too and expose the thing. Then open the Grafana and we can monitor our application. The same way we deploy this thing right before in our first. I'm coming to the Grafana Prometheus lab. We already deployed the thing. Similar way.
Yeah, we have done already. Yeah.
Yeah, similar. Just yeah, go through this. This is why I mean we couldn't see the not utilization or pod utilization because in this given cluster the metric API is not available. So we need to enable or install the metrics API. when this up and running, we can see the status of, yeah, it's now done. Okay, see, metric service run. Now we can check the CPU node utilization using top node. Okay, top node. See, these are our node. This 2 is percentage utilization, and this is 2. The one is utilization is 4%. And similar way, we can utilize the memory. Coming to port, we can utilize. We can see the utilization. CTL top ports. If these boards are running in these nodes. Okay. So we can wind up, right? All of you. I will share the ender YAML and the segregated YAML also. Split YAML. Just to go through, then you will get idea. Okay. And you can deploy the same thing in Kubernetes or managed EKS or self-hosted Kubernetes cluster. Okay. If we are go with self-hosted, then there is no load balancer. So for the load balance, the front end, external front end, choose node port. And copy the IP of the worker node. Got it. Anyone hand out? Or else we can wind up, right?
Okay, thank you.
Yeah, okay.
Thank you, sir.
Yeah, goodbye. Pay all.